Hello, welcome to my Pre-Algebra review series. This video covers Chapter 6, Section 1, titled Ratios and Unit Rates. By the end of this section, you will have reviewed the procedures for writing ratios, finding rates and unit rates, and finally converting rates by means of dimensional analysis. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Definitions. A ratio. A ratio is a comparison of two numbers by division. You can write a ratio in different ways. Rates. A rate is a ratio that compares quantities in different units. Unit rate. A unit rate is a rate that has a denominator of 1. Examples of unit rates include price, gas, mileage, speed, etc. Objective 1. Writing ratios. Statistics. In the United States, about 10 out of every 15 people eligible to vote are registered to vote. The numbers 10 and 15 form a ratio. Key concept, ratio. A ratio is a comparison of two quantities by division. You can write a ratio in different ways. Algebraically, you can say A to B, A colon B, or A divided by B. Arithmetically, it can be 10 to 15, or 10 colon 15, or 10 divided by 15. Example 1, real-world problem solving. So a survey. A survey asks students whether they had an after-school job. Write each ratio as a fraction in simplest form. So for A, it says, students with jobs to students without jobs. Well, if we look at our chart, we see they have job, 40 students out of 100 had a job, and 60 did not have a job. So students with jobs was 40. Right here you see the 40. And students without jobs is 60. Right here. Okay? And that ratio, 40 to 60, is 2 to 3, because you can divide 40 by 20 2 times and 60 by 20 3 times. How about a ratio here? Students without jobs to all students surveyed. Well, that would be students without jobs, 60. Over here, here's the 60 students without jobs, and the students surveyed. Every student surveyed was 100. Here's the 100 surveyed. So the ratio is 60 over 100, 60 to 100. And the same as we did with the 20s, 20 goes into 63 times, 20 goes into 105 times. So the answer here is 3/5. Example 1, check your understanding. So we're going to go and write each ratio as a fraction in simplest form. Excuse me, I had to cough just then. Problem A, you're going to do these, B, on your own. So go ahead and pause the video, and when you're done, come back and we'll do them together. Okay, now that you've had that time to complete these two problems, let's look at them. Students with jobs to all students surveyed. Well, students that have jobs, right here is 40. We're going to say 40. And the ratio is 40 to all students surveyed, 100. Well, so there it is, 40 to 100. But we're going to in simplest form. They want it in simplest form. So what is that? We can divide 40 and 100 both by 20. And if we do, 40 divided by 20 is 2. 100 divided by 20 is 5. So the answer here is 2/5. Let's do B, students without jobs to students with jobs. Okay, students that don't have a job, right here, don't have a job, is 60. And that is over how many students that with jobs, right here? 40. So 60 over 40 is equal to, again with the 20, we're going to divide by 20. 60 divided by 20 is 3. And 40 divided by 20 is 2. There's our result, 3/2. And we could take it one step further and we could say 1 1/2. Okay? Good job. So in Objective 2, finding rates and unit rates. So there's a definition here. A rate is a ratio that compares quantities in different units. That would be like miles per hour kind of a thing, right? 2 different units. So a unit rate is a rate that has a denominator of 1. Examples of that of unit rates include the unit price, gasoline mileage, speed, miles per hour, gallons per whatever, gas mileage, gallons per mile, or miles per gallon, whatever. Okay? Okay, in example 2, real-world problem solving. The table shows the price for different sizes of dish detergent. Which size has the lowest unit price? Okay, so the regular price, we have regular, family, over here we have, where'd my pen go? Regular, family, and economy. In the regular, the volume is 12 fluid ounces, and the price is $1.20. So we have regular is price and volume. $1 right here, $1.20 per 12 fluid ounces. See, 12 ounces right here, and it's $1.20. So the price is $1.20 per 12 fluid ounces. If you carry that out and do the division, 120 divided by 12 is 10 cents. $0.10, 10 cents per fluid ounce. So the 12 fluid ounces is gone now. It's just a unit number. 10 cents per fluid ounce. Family size, the price, $2.24. Here it is, $2.24. Family size. Per what? Per 28 fluid ounces. Here it is. How many fluid ounces do you get for $2.24 in the family size? Well, it's $2.24 divided by 28 fluid ounces, and that is $0.08 or 8 cents per fluid ounce. Okay? And the units here are dollars per fluid ounce. So you see that, dollars per fluid ounce. How about the economy size? The price, $3.60. How many ounces do you get in the economy bottle? You get 40. So it's $300.60 and 40 fluid ounces. If you do the division on this, it's $0.9 or 9 cents per fluid ounce. Well, an interesting thing here is what? The economy, you would think economy would be the cheapest, but it's not. It costs less to buy the family size in the 28-ounce bottle. So the family size has the lowest price per fluid ounce. Example 2. Let's check your understanding. The directions are write each ratio as a fraction in simplest form. So you'll get a fraction and then put it in simplest form. Why don't you go ahead and stop the video? When you come back, we'll take over from there. Okay, now that you're back, so what are we looking at? It says 2 liters of spring water costs $1.98. So that's like the soap or whatever it was, right? It's $1.98 for 2 liters. Dollars per liters, right? So we're going to write that. We're going to write $1. I could write the $1.98 divided by 2 liters. I think it's capital L. They like 2 liters. So it's $1.98 per 2 liters. So how much is that per liter? Well, in order to get out the price per liter, the unit price, we're going to divide each by 2. So now it's 1 liter, and $1.98 divided by 2 is equal to 99 cents per, I'll put a 0 right there, per liter. That is the answer, 99 cents per liter. How about this one? A car goes 425 miles on 12.5 gallons of gas. So what is that? That's miles. How many miles can it go on 12.5 gallons? So it's miles, 425 miles, right? Divided by gallons of gas, 12.5 gallons, G-A-L of G-A-S, right? In order to get that ratio now, we're going to take the 425 and divide it by 12.5. And when you do that, you're going to find out that it's 34 miles, and you've seen this before, miles per, the 12.5 disappears per gallon, right? Per gallon, G-A-L. And we know it's gasoline. So there's the answer, 34 miles per gallon. You've heard miles per gallon probably as long as you can remember back. You've even heard your dad talk about, or your mom or someone talk about how many miles per gallon are we getting. So here it is, miles per gallon, 34 miles per gallon. There's our solution. Example 3, converting rates. It says you can use dimensional analysis to choose conversion factors for converting rates. So let's convert 10 miles per hour, 10 miles per hour to feet per minute. So there's going to be two conversions. We have to convert hours into minutes and feet into miles. So how do we do that? We can start off simply by multiplying by a conversion factor. The 10's not going to go anywhere until we actually can divide it or multiply it or whatever. But we have to convert miles per hour to feet per minute. We're going to do, but we can convert this to feet, right? How many feet per mile? So we have a mile up here. We want to get rid of the miles. So the first thing I tell you to do is draw a line and put miles on the bottom. Miles are on the top. You want to get rid of it? Put miles on the bottom. So once you put the miles on the bottom, you need to know, well, how many? Oh, we want to go to feet. So, and you want feet on the top. So I'm going to put feet on the top. And I'm going to say, how many feet per mile? Feet per mile. It's 5,280 feet per mile. So that conversion factor here they're talking about, choose the conversion factors. That's it right there. So now we've got that one, and we can carry this out. We can say is equal to what? 10 times 5,280 is 52,800. And we have feet, because guess what? The miles cancel now. Miles over miles. So it's feet per, and the hour is still here. We haven't touched the hour. Okay? So now the next step. Now that we have the 52,800, we can say 52,800 feet per hour. And we want to get rid of the hours and make it minutes. So in order to get rid of the hours, what did I say up here? I said draw a line, and if you want to get rid of whatever you want to get rid of on top, you put the same thing on the bottom. Same thing on the bottom to the top. So in this case, we want to get rid of the hours, so I'm going to draw a line, and I'm going to put the hours on top. Okay? And then what do I want on the bottom? I want minutes. So here's minutes on the bottom. So how many hours and minutes, what's the exchange there? So it's 1 hour is equal to 60 minutes. Correct? So now when I go ahead and do my math, this hour here, this 1 hour here is going to cancel with that 1 hour. And I'm left with feet. I'm left with equal to 52,800 feet per 60 minutes. Okay, so now I have the feet per minute. Here it is, feet per minute. I've made it. I now have 50 feet per minute, but I have 52,800 divided by 60. So I have to do that final division, and that final division will give me, if I do the math, it's going to give me 880 feet per minute. And here it is, equals 880 feet per minute. Okay, example 3, check your understanding. Complete each statement. Go ahead and stop the video and try it on your own. When you come back, we'll start up again. Okay, now that you're back, we're going to start this at problem A. We're going to say 3.5 quarts per minute is equal times, we want to go to gallons per hour, right? Gallons per hour. So we're going to convert this to gallons per hour. And that is, what do we want? We can go get rid of the minutes, or we can get rid of the quarts. Let's get rid of the quarts first. So in order to get rid of the quarts, I'm going to draw a line, and I'm going to go to gallons. So I'm going to draw a line and put quarts on the bottom. Okay? And gallons on top. So now I've got gallons per quart. And how many gallons per quart? 1 gallon per 4 quarts. And when I do that, the quarts here disappear. They cancel because the quarts divided by quarts is 1. So now I have 1 gallon over 4, so it's 3.5. We're going to write it out one more time. I'm going to say 3.5. The quarts are gone. And what's left now is gallons. Gallons divided by 4 minutes. 4 minutes. Okay, so now we've gotten to the gallons part. Now we have to get to the hours part. So in order to get rid of the minutes and go to hours, we have to get the minutes have to be removed and replaced with hours. So we're going to put the minutes on top because it's in the denominator here on the left. We're going to put it in the numerator to get rid of it. And we're going to put, what do we want to get to? We want to get to hours, or whatever the next conversion. You could have 4 or 5 conversions here. We want to get to hours. So it's minutes over hours. Okay. And then how many minutes? 60 minutes per 1 hour. Okay. Now we can do the math on this. We can say there's no more multiplying, no more. So we're going to say this equals what? 3.5 times 60. Okay, 3.5 times 60 gallons. Oh, don't forget the minutes cancel here. Gallons over 4 hours. So it's gallons per hour, and it's 3.5 times 60 and divided by 4. Well, I'm going to take it a step further. I'm going to say that I'm going to divide the 4 into itself and get a 1, and 4 into 60 and get 15. So 3.5 times 15 divided by hours and gallons. Okay, 3.5 times 15 gallons per hour. And when we multiply that out, we're going to get 3.5 times 15. 15 times 3 is 45. A half of 15 is 7.5. 45 and 7.5 is equal to what? 45 is equal to 52.5 gallons per hour. The hours are here, the gallons are here, and we just had to multiply those together. So let's go do this one now. Centimeters per second. 12 centimeters per second times, we want to go to meters per hour. So let's get rid of the centimeters. So I'm going to draw the line because I have a fraction going in, and I want to get rid of the centimeters. So I put the centimeters on the bottom on this side because it's on the numerator here. I put it in the denominator here, and I'm going to put the meters on top because that's what I want to end up with, meters on the top. So now I'm going to take, and these centimeters are going to, well, before I do that, I'm going to say 1 meter is 100 centimeters. And now the centimeters are gone. And I can carry this out. I can say 12 meters, 12 times 1 meter, over S times 100, or 100 seconds. Now I want to get rid of the seconds. So I'm going to multiply again. I'm going to draw another line. And I'm going to say, oh, I want to get rid of seconds. Seconds is in the denominator, so guess what? It belongs in the numerator up here. And I want to get to hours, so the hours now go in the place that's left, which happens to be in the denominator. And what is it? Seconds per hour. How many seconds is it per hour? It's 60 seconds? No. It's, excuse me, I jumped the gun. Come on. There you go. Sorry, taking so long on that. It's 60. I'll do it down here. 60 times 60 is 3,600. So it's 3,600 seconds per 1 hour. We could have done it in 2 steps. I could have said 60 minutes per hour. And then I gone to the next phase, which would have been seconds per minute. I could have done that. So it would have been 60 seconds. I would have still got my 60 times 60 in here, and I would have ended up with seconds. But I would have had the one step of going to minutes per hour, and then to seconds per minute. But we made one big leap, 3,600 seconds per hour. Okay, so everything is done now except for crossing out the S for the seconds. And I'm now left with 12 times 3,600 is equal to 12 times 3,600 divided by 100 hours. 100 hours. And that is equal to, I can divide the 100 into 3,600 and get 12 times 36. Okay, 12 times 36 meters. I could have put the meters in here too, by the way. Meters divided by 1 hour. Meters per hour. Meters per hour is what they're looking for. And it's 12 times 36 meters per hour. And 36 times 12 ends up having to be 432 meters per hour. And there's the solution to that. Good luck.